Nice to hear, nice to see you on our conference, on our fifth plenary session. Now we have a very good possibility to discuss very interesting topics related to development of technology based on artificial intelligence tendency in this very hot domain of research and development. And I sure that keynote speaker, Professor Yuri Pantelyevich Kondratenko, will help us to better understand this very interesting research topic. It's my pleasure to invite Yuri Pantelyevich Kondratenko for this presentation. Professor Kondratenko is Doctor of Science. He is Professor of Intelligent Information System, National Black Sea University, named of Mogila in Nikolaev. He is leader researcher of Institute of Artificial Intelligence, corresponding member of the Royal European Academy of Science, academician of the Academy of Shipping Building Science of Ukraine, honored inventor of Ukraine, author of 150 inventions and 10 monographs. He is author of 190 papers published and indexed in Scopus. He is famous specialist in area intelligence system, fuzzy logic system, and mathematical and engineering methods of development intelligent industrial system. It's my pleasure to invite Professor Kondratenko for his keynote lecture. Welcome, dear Professor, dear Yuri.
Good morning, dear colleagues.
Good morning.
Thank you very much. Thank you very much, Vyacheslav Sergeyevich, for your kind introduction. And let me share my screen.
Yes, welcome.
Can you see my slides?
Yes, we see, we hear you. Thank you. Welcome.
Is it switch on?
Yes,
yeah.
Yes.
Okay.
All is okay.
So,
thank you.
So, dear colleagues, today we will discuss the topic analysis of the priorities and perspectives in artificial intelligence implementation. This is, you can see, this is a group of authors who took part in preparation of this paper. So let me start. The main component of this presentation are introduction, analysis of the world's priorities in AI implementation based on national AI strategies, priorities of AI research and implementation for NATO, the stages of AI strategy creating and key priority areas of AI implementation in Ukraine, discussion of some perspective proposals and research trends in contemporary AI and its implementation, and finally, conclusions. Artificial intelligence availability and effectiveness of its adoption will be a criterion for assessing the rank of economic development. The attractiveness of countries and regions the concentration of skilled workforce, high-tech enterprises, educational institutions, material and financial resources, and cultural heritage will depend on the level of AI implementation. Methods and means of AI are widely used in robotics and automation, national defense, space industry, state administration, etc. Current AI technologies become true amplifier of research and scientific discovery. For example, researchers have decreased based on using AI a complex quantum problem from 100,000 into only four equations, providing the same accuracy. AI implementation can lead to revolutionary results. Among the most promising AI directions are natural language processing and language models, large language models, generative adversarial neural networks, image generating models, system of artificial computer vision, intelligent robotic, and others. Next part is analysis of the world priorities based on national AI strategies. Experts' predictions for 2030, the use of AI will increase GDP in China by 26%, North America by 14%, and Europe by approximately 10%. 50 developed countries, which represent 90% of global GDP, have already created national strategies for AI development with a formulation of goals, tasks, and priorities in the AI area. Current national AI strategies are presented in different forms, like systematic strategies or roadmaps, action plans, conceptions, or executive orders. Here you can see flags of all 50 countries around the world who create and approve the strategies for AI development and implementation. Now let's consider the list of selected countries and analyze the priorities in AI implementation based on national AI strategies. Australia strategy is like roadmap, and main priority areas are healthcare, infrastructure, and natural resources. Austria, the strategy outlines areas for which AI will be critical: research and innovation, society, ethics and labor market, qualification and training, AI governance, security and law, AI in the public sector, infrastructure for industrial leadership position, and AI in the economy. Belgium, the AI strategy included 7 goals: policy support on ethics, regulation, skills, and competencies, provide AI cartography, co-animate Belgian AI community, collect EU funding, and connect EU ecosystems, training in AI, implementation AI technologies to the industries, and new products and services based on AI technologies. Estonia, 4 key goals: advancing the AI update in the public sector, advancing the AI implementation in the private sector, developing AI research and development and education, and developing a legal environment for the AI introducing. India, AI strategy aims to enhance the skill to find quality jobs, invest in research and sectors that can maximize economic growth and social impact, scale Indian-made AI solution to the rest of the developing world. Estonia, sorry. Something happened with my slides. Okay. Kenya, priority areas, financial inclusion, cybersecurity, land tilting, election process, single digital identity, and overall public service delivery. Lithuania, AI is planned for implementation in the public sector for crime prediction, developing better services for citizens, and improving internal government process. South Korea, three main objectives: growing AI talent, special training programs and AI graduate schools, developing AI technology by finding major projects in health, public safety, and defense, and investing in infrastructure, creating AI semiconductors for autonomous vehicles. Sweden, main focuses of AI strategy, training more skilled AI professionals, increasing applied and fundamental AI research, creating a legal framework to ensure the development of AI applications that are ethical, safe, reliable, and transparent. United Arab Emirates, 9 priority areas for AI implementation: transport, health, space, renewable energy, water, technology, education, environment, and traffic. And last but not least, United States of America focuses of AI strategy, investing in AI research, unleashing AI resources, setting AI governance standards, building the AI workforce, and protecting the US AI advantages. Experts predict that AI can provide an increase in cumulative GDP by 2030 by about 16%. National AI strategies have developed also in Argentina, Colombia, Finland, Indonesia, Israel, Italy, and other countries. Next part is priorities of AI research for NATO. AI has become an integral component of modern warfare and national security in conditions of rapid technological development. NATO member states have recognized the significant potential of AI to transform their defense strategies, streamline operation, and enhance military capabilities. The NATO Science and Technology Organization published Science and Technology Trends for 2023-2043 across the physical, biological, and information domains with the priorities of AI development and implementation for the next 20 years. AI, a technology for improving operational awareness by processing and integrating data from various sensors, platforms, and intelligence sources in real time. AI can help a more complete understanding and predicting of potential risks, adversary intentions, and the impact of various strategic decisions, as well as detecting anomalous or suspicious activity, informing decision maker on potential dangers. The use of AI as part of the NATO defense planning process and DPP is very important. The proposed NDPP may be considered as key mechanism that manages the development of NATO military capabilities, ensuring the alliance readiness and ability to respond to new security challenges. AI can significantly improve NDPP by increasing planning efficiency, providing better insight, and optimizing research allocation. You can see here the structure of NDPP, the NATO defense planning process. The main components are the political guidance, the determine requirements, then apportion targets, facilitate implementation, and review result. The following set of priorities can be considered when using AI to support NDPP. AI technologies are an organic ecosystem for analyzing NATO current capabilities and more effectively identifying weakness. AI can be used to optimize the formation of forces and their readiness, ensuring the efficient distribution of personnel, equipment, and other resources. AI-based algorithms allow analysis of personnel skill, equipment availability, deployment history to determine the most appropriate force composition for specific missions. AI can help to predict future needs, allowing NATO countries to better plan the resources and capabilities they need. Effective allocation of resources and optimization of military forces are vital to maintaining NATO's strategic advantage. AI can support NDPP by improving training and education program for NATO personnel. AI main role in this area is to help develop individual training plans, ensuring that personnel are properly trained to perform their duties within the alliance. The war in Ukraine revealed insignificant problems of NATO in the field of interoperability and interchangeability of weapons and military equipment. AI can help NATO countries address these challenges and ensure that their military forces work together as seamlessly during operation. AI can facilitate the development of common standards, protocols, and architectures that facilitate greater integration and cooperation among alliance members. A main condition for the successful implementation of the NDPP is effective logistics and management of the necessary supply chains. AI can help optimize these processes by analyzing data on resource availability, transportation network, and demand patterns. AI can assist in development of autonomous vehicles and drones that can be used to solve logistic tasks, thereby reducing the need for human intervention in high-risk situations. AI-based system can analyze vast amount of data to detect cyber threats and intrusions, response in real time, and even predict and prevent future attacks. AI can support information operation, disinformation campaigns, and psychological operations to counter hostile narratives and influence target audience. Next part is stages of AI strategy creating and key priority areas for Ukraine. More than 2,000 software development companies specializing in AI in Ukraine. Ukraine ranks 31st in the world ranking according to Global Open Data Index. As step one, conception for AI development and implementation, approved by Cabinet of Ministers of Ukraine in December 2020. This conception defines the purpose, principles, and tasks of the development of AI in Ukraine as one of the priority direction in scientific and technological perspective. As step two, it is necessary to create a systematic strategy for the development of AI in Ukraine. In 2020, the Institute of Artificial Intelligence Problems in Kyiv started the project Creating Strategy for the AI Development in Ukraine. You can see here the title page of the book, which devoted to this strategy for artificial intelligence development in Ukraine. The developed version of AI strategy is based on the national characteristics and interests, the necessity to extend AI research and implement AI in different fields of Ukrainian economy. Institute of Artificial Intelligence Problem involved about 300 different organizations for the determination of the priorities in AI implementation. So let us focus on the priority areas for development and implementation of AI in Ukraine according to the developed AI strategy. Among them are science and education, healthcare and medicine, industry and energy sector, telecommunication, transportation and social infrastructure, agriculture, ecology, national security and defense. Science and education. Appropriate development of educational centers is planned for the possibility of training personnel in the AI field. Transdisciplinary clusters must be created to monitor the development of students and the compliance of educational programs with society challenges. Medicine. The main AI tasks in medicine is formation of a national electronic healthcare platform, improving the protection of personal medical data, improving the regulatory framework and ethical control of the use of AI related to healthcare, the introduction of intelligent robotic and autonomous medical technologies, etc. Industry and energy sector. The implementation of AI solution must be directed for creating fully automated industrial plants, enterprise management, information analysis, planning and forecasting in energy security, flexible management of energy consumption, etc. Telecommunication. The AI implementation must be aimed for development of mobile communication infrastructure, the use of AI to solve typical operators' problems, the implementation of AI system for geographic targeting and analysis. Transportation and social infrastructure. The AI implementation must be planned with the aims of forecasting traffic flow and optimizing routes of public transport systems, increasing the safety of transport, intelligent traffic management, etc. Agriculture. Several directions of AI application in agriculture can be planned. It is like prediction of weather condition and climate changes, optimization of irrigation and fertilization systems, monitoring of plant conditions, soil analysis, and automation of sowing, harvesting, sorting, and packaging of product. Ecology. Autonomous monitoring for optimal use of nature and restoration of land and water resources is seen as important direction of using AI robotic systems. And finally, national security and defense. AI technologies can be used for military goals, but AI research, developments, and implementations should be agreed upon with high ethical and moral principles. Besides the priority areas for AI implementation in Ukraine, according to approved AI conception, are cybersecurity, information security, public administration, justice, legal regulation, and ethics. Next part is discussion of some perspective proposal in AI research. So let us discuss some perspectives, tendencies, and authors' proposal in research for AI software and hardware solutions, and analyze the peculiarities of corresponding results of AI implementation in the selected and very important areas of human activity, like healthcare, defense, and education. 5A. Perspectives of applied AI research development for healthcare. AI continues to be a high research interest in healthcare. Example, the models created using a computational system virtual epileptic patient VEP have been developed as part of the Human Brain Project HBP, a 10-year European initiative focused on digital brain research. The AI achievement can improve the accuracy of medical diagnosis, predict patient outcomes, and etc. Task 5A1. AI will be widely used to identify potential drugs candidates and accelerate the drug discovery process. Example, Spotify founder and CEO Daniel Ek have launched a new health tech startup, Nico Health, which aims to offer full body scanning to help doctors detect and prevent disease. The non-invasive treatment will take about 15 minutes. The examination will collect over 50 million data points about the skin, heart, vessels, respiration, inflammation, and more using AI technology. Task 5A2. AI can also improve the efficiency of healthcare delivery by providing patients with personalized advice and optimizing hospital operation procedure, such as predicting patient admissions rates and scheduling maintenance. Task 5A3. The current state of AI in medicine has demonstrated promising results in improving diagnosis and treatment, enhancing patient care and experience, and optimizing healthcare operations. Ongoing research and development efforts in applied AI for medicine are focused on addressing challenges such as bias and standardization while exploring new applications of AI in medicine. As AI continues to evolve, it is essential to ensure that its use in healthcare is safe, effective, and equitable. I can't see some slides. Okay. So part 5B, applied AI research and development for the country defense. AI promises to change the traditional approach to national security. One of the most important aspects to defense research is situational awareness the ability to identify, process, and understand information in real time. Advanced AI-based surveillance technologies and systems have revolutionized the way military forces gather and process intelligence. Task 5B1. Using computer vision, this system can automatically analyze huge amount of data from various sources, such as satellite images and drone footage, data from various sensors, videos, cameras, etc. This enables rapid identification of potential threats and accurate assessment of enemy movement, ultimately leading to more informed and effective strategic planning. This will allow commanders to quickly find out the current situation on the battlefield and quickly respond to its critical changes. Thanks to just a moment. Thanks to the well-developed technology of image synthesis based on textual descriptions, it will finally be possible to realize the military dreams of automatically displaying and updating the operational situation on maps. On this figure 2, you can see the transformation of combat reports into an operational graphic situation on maps. It is quite possible to supplement this process with the function of converting voice into text and then into images and synthesis of 3D virtual reality sense. This figure 3, you can see the transformation of voice commands into symbols of the graphic situation on the maps. It is quite realistic to implement the reverse process when AI is used to synthesize the text of draft combat orders based on the result of updating the local tactical symbols on the commander's combat map. You can see here this synthesis of the text of combat order based on the results of updating graphic images of the tactical situation. Task 5B2. Another area of large language models implementation is analysis of moods in units and among the population to identify potential threats, and the use of machine translation to facilitate communication between soldiers who speak different languages. Task 5B3. AI plays a crucial role in the increasing resilience and adaptability of communication networks. Machine language processing and machine learning algorithms can detect and counter cyber threats such as hacking and blocking attempts that ensure secure and reliable communication channels. Neural network technologies of coding and demodulation of signals allow to increase in bandwidth and immunity of radio data transmission channels. This aspect is especially important due to widespread use of autonomous systems and robotics in modern warfare. Task 5B5. Robotic system based on AI significantly change the rules of warfare, reducing risks to human lives and expanding combat capabilities. Drones can work in swarms, in which collective AI should increase their efficiency and ability to overcome enemy defense in conditions of heavy fire resistance and radio electronic warfare. Similar ground warfare and underwater robotic systems based on AI are developing to assist in variety of military tasks, such as mine clearance, siege, and etc. Task 5B6. As the role of AI in identifying vulnerabilities to counter disinformation campaigns and a secure digital landscape is constantly expanding. AI-driven cybersecurity systems can effectively detect and neutralize cyber threats in real time. Disinformation campaigns pose a significant threat to national security in the era of information wars. AI-based tools can help detect and counter such threats and by analyzing various sources, including social media and news outlets. Next part is AI perspective in education based on the academic consortia. I'm sorry. Education is a key sector that allows nations to realize their AI ambitions. Academic consortia of the universities can significantly help in AI cadres preparation. Exchange students and high caliber professors, implementing the cross-registration procedure, and sharing computers, libraries, and other resources and facilities in the framework of AI academic consortia can provide high-quality training the specialists in all universities that are members of the corresponding academic consortia. AI academic industry consortia that can promote the high-speed implementation of AI innovation solution and startup results to the industry, agriculture, and public sectors. Example, Canada USA United Ukrainian University, UUU, is an innovative online education platform from Coursera and edX for Ukrainian universities, with the features a full cycle of training with the help of the EDU intelligent bot. Catalog of educational programs consisting of 6,000 courses, virtual reality training, gamification of learning. Next example, AI Academic Industry Consortium deals with introducing the idea of Sheep Knowledge Center 5.0. Appropriate innovation projects are on the go within Ukrainian Maritime Cluster in cooperation with advanced SEA Europe members. A prototype of such SKC has been operational in the National University of Shipbuilding in Mykolaiv since 2009. Then the Accelerated Training Program, ATP, developed in Aker Yards Design Ukraine office, was relocated to Maritime Instrumentation Department Training Center, MIT-TC, with appropriate hardware and software. Initial ATP was modified to the current needs of Ukrainian shipyards and design offices by MIT staff. Last decades, the shipbuilding university faced new specific challenges. First, while many students have successfully executed key training tasks concerning the design and engineering provision of ship hull manufacturing, very few have been ready to replicate the acquired skills across solving other similar practical engineering tasks. Second, despite the accelerated adaptation of graduates to full-scale development of 3D models of ship structure, junior specialists still have to develop their knowledge to gain unique skills to deal with specific of different type of vessels, building shipyards, digital modeling software, ship owners and operators requirements, dominated weather on marine routers, classification, bodies and industrial standards, etc. 3. The role of university faculty is minimal in covering gap between the horizon of the practical knowledge and the vast set of return of experience system data at engineering, manufacturing, and service entities. De facto, the first revision of SKC was already tested and operating in 3 laboratories on the irregular basis, short-term project, within framework agreement between members of this academic industry consortia, National University of Shipbuilding, Aker Yard Design Ukraine, Marine Design Engineering Mykolaiv, Sea Job Nikolaev, Aveva, Kadmatic, Schneider Electric, and Amico Group. The industry supports the development of training centers, material base, equipped with new generations of workstations, internet connections, and joint updating of training programs and extracurricular courses, including multimedia instrument of online education and practical training. And they are first employees of mid-TC graduates who grow in their professional career very fast and now are working as lead engineers in several countries and international shipbuilding groups. Next step is the conscious paradigm of AI design. Special attention to future research in AI should be paid to creating AI based on consciousness and conscious paradigm. Let us further assume that AI is conscious, reasonable, and adheres to ethical, moral, and legal norms. Here you can see this figure number 4. This figure shows the developed functional model of a new generation computer system with embedded AI, which is a basis for future research in AI in personal context. You can see here additional blocks like artificial conscience and artificial consciousness. During its creation, knowledge can be used to build a real scheme of conscious activity with a system of control over decision made. 5E, perspectives of organoid intelligence. Recently, there has been growing interest in combining organoid with AI to enhance their functionality and create organoid intelligence, OI. By analyzing large database of organoid behavior and responses, researchers can gain new insight into organ development and the nature of disease pathology, which would be difficult to achieve with traditional experimental methods. The human brain outperforms machine for solving certain tasks. Organoid intelligence could allow for the study of personalized brain organoids developed from sample of patients suffering from neural disorder. Here in this figure you can see intestinal organoid, and computer vision algorithm can be used to analyze microscopic images of organoid and identify patterns of cellular organization and differentiation. This algorithm allows to the monitoring of organoid development in real time, providing scientists with valuable insight into the dynamic of organoid formation. This is another organoid like brain organoid. US researchers explore the potential of biocomputers and plan to use organoid, which will eventually lead to OI organoid intelligent system. It will be clustered from 50,000 brain cells grown from stem cells. Next part is polymetric sensor for modern industrial AI-based system. Future AI research closely deals with the development of new sensor system based on various physical principles with extended functional possibilities and improvement of technical characteristics. One of the perspective direction in this area is polymetric sensory systems. The special research will be focused on integrating digital polymetric and multivariate sensors into modern industrial AI-based system to increase production entities' overall efficiency and provide the dual green and digital transformation. Polymetric sensors for modern industrial AI-based systems. The innovation in the PSS approach lies in combining three key elements: certified and market-proof sensors, a secure and resilient data transport and storage system, and proven data analysis instrument for operations, anomaly detection, and failure prediction. By integrating these elements into a single system, critical infrastructure operators can more effectively monitor and protect their object and detect potential issues before they become pressing problems. As an example, let's consider the generalizer of sensors for the cyber-physical system supply vessel. The main sensory components or sub-agencies of the cybersecurity, cyber-physical systems are. So you can see this supply vessel with some of these information components. So main sensor here are radar antenna, an onboard anemometer, a set of sensor for ship draft monitoring, a set of polymetric sensor for fuel oil, ballast water, and other liquid cargo quantity and quality monitoring and control, a set of polymetric sensor for liquefied LPG or LNG cargo quantity and quality monitoring and control, and sensor for real-time monitoring parameters of ship dynamics. And finally, last part is optical computing and quantum computing for the design of AI hardware. The main goals for the development of new hardware solution for realization, for AI realization, deal with extending memory storage and increasing the speed on information and signal processing. Among perspective approaches for future implementation in the hardware of real AI system are optical, color optical, and quantum computing. Optical computing allows the creation of hardware for AI systems with faster computational compared with existing computer system and maximizing communication speed between different parts of computer systems. Color optical computing may allow us to get robust computations and robust communication, providing reliable and high accuracy computation in the condition of noise as the main disturbances in signal and information processing. So here I just present one reference, why color optical computer, which will be maybe useful for some researchers. Quantum computer promise to solve problems that are beyond the reach of classical machines by harnessing phenomena such as quantum superposition. Here also you can see the two references, and especially the second one is very interesting, the Odyssey to next generation computer, cognitive computer inspired by brain and powered by intelligence mathematics. It is in journal Frontier in Computer Science. So next part is conclusions. This presentation consists of a detailed analysis of the priority areas for AI implementation in different countries based on their national AI strategies in NATO countries and in Ukraine. The presentation also focuses on some advanced research directions which may have a significant influence on the development and implementation of new AI solutions. The proposed approach for creating a new generation of computers with embedded AI based on moral and ethical principles have very high expectation, and its creation is an important task for future research. AI developers from different countries should work together to establish common ethical standards and principles governing the use of AI in defense, medicine, and other fields, as well as AI research should be directed to minimize bias. Research should be directed to minimize bias, improve explanatory power, and ensure the technology compliance with international humanitarian law and human rights principles. Thank you very much for your attention.
Thank you very much, Yuri Pantelevich, for your fundamental wide picture of AI development in the world, in the Ukraine, in NATO, and so on. Now we have time for short questions and discussion. Welcome.
Okay.
One of the questions was asked by Dr. Irina Leroy in chat. A question will be AI implemented into the current medical evidence-based medicine database like DINA, MED, and PBMed? Your colleague, your co-author, Dr. Alexander Stryuk, answered to this question, but maybe you would like to add something concerning...
Professor Vyacheslav, if I may also contribute into what I said, it's Irina speaking. So first of all, thank you very much. It's impressive presentation, and I'm very happy that in spite of that I'm on road, I be able to connect. So I don't see the chat, so I don't know the answer, but exist, of course, evidence-based medicines, and those were very well-known databases that I know by heart. And those databases are definitely need your research. And if you have questions, I can approach the people who invent this database and who supported them. And the second question, honestly, of your research, it's something that already I have seen, or it is on the pipeline of some companies in Europe who is already implementing this in the real life. So if you or your assistant could keep in touch with me, I can also give you the contacts to the people or to the findings who is supporting your database and providing you who can support your databases to your research and providing additional findings to your research, because I do believe that it's very important. And I know at least 3 funds and 3 companies who is actually need your suggestions, or even they could hire your kind of have you as an expert in their teams. I am on road, so you can just please feel free to reach me out through the conference organizers. Thank you.
Thank you very much for your proposal. Of course we will contact you. Please put your email address to the chat, and my colleague Alexander Struk and me, we will contact you. You know, it's this very interested for us, this database in medicine, because we have some experience to image recognition and for diagnosis different disease, for as liver disease, lung disease, and heart disease. Some decision support system which can help for medical doctors to make right decision, and so on. It really will be interested in such cooperation and such collaboration in this research, and maybe we will also find some additional points for cooperation with you and your colleague. Thank you.
Thank you.
Thank you very much for this comments, this discussion. And the next question is Maxim Andreychuk. Welcome.
Yes, may I ask the question? First of all,
welcome,
thanks
please.
for your presentation. It's very interesting to listen. But if you take the combat use of AI as an example, if you can set up for drones and UAV, how exactly can we start training them? That is the principle of training. And how much time and money would it take, theoretically?
I know, you know, it's special questions for wartime, and you know, it's depends on the kind of drones, and depends on the missions of drones. It depends on is this drones only with video camera, or is this drones with some explore equipment and something like that. So it is you know, I know some people in practitioners in this area, including 2 people who are included to Guinness book as recordsman in the drones lasting flight. So drones how much time to be drawn in the flight, you know, without as autonomy object. So I think it's special questions. We can discuss it maybe later.
All right. Thank you for the answer.
Thank you. Other questions? I have one question. For us, if we talk about characteristics of AI systems, one of the most modern is characteristics of ethics. Before AI era, we did not talk about ethics of traditional technical system. What is your opinion? Why these characteristics was added for assessment of AI quality as one of the key characteristics? Similar trustworthiness, responsibility, explainability, and so on. Thank you.
I'd like to say that implementation of AI have some challenges, of course. No, first of all, it's will be some changes in labor market because some profession will be disappeared and new profession will be appeared. But this is another problem is really ethical problem, because as usually we have instrument, but this instrument have two sides, like positive and negative. Oh, as example, for example, in China, one specialist was arrested. Why? Before he using artificial intelligence produced the news about the train catastrophe with victims and so on and so on. And it was disseminated, and about 20 companies took this information and disseminate, and so on and so on and so on. Another fact, for example, in Spain, the people took pictures from school girls from social media, took this picture and then transform this picture without clothes and send this picture to the social media. So as in usual case, when we have when we have instrument, it is possible to use it for good things and use it for bad things. And according to AI, it's very important that, as former CEO Google said, that AI will be such talented and such good as designer who made this AI. So if designer good person, so we will have good result. If designer not good person, but not designer, but also user can use it for different, so like, for example, fake news and so on and so on and so on. So this is the reason why this ethical problem was appeared concerning to AI development and implementation.
Thank you. I think it's a really very important topic, and the task is the following: how we can, as engineers, assess ethical issue for AI system, and say it's very interesting research and development problem. Thank you. Any other questions or comments, dear colleagues? No? Thank you very much, Professor Yuri Panteleyevich Kondratenko, for your very interesting lecture, very interesting discussion. And thank you very much that you now in the middle of the night in other continent, and you join us.
Now 3 o'clock a.m.
Yes, 3 o'clock. I think it is not usual lecture for you, but in such condition, it was very interesting and very useful. Thank you very much.
Thank you very much. Thank you.
Thank you. Okay, dear colleagues, so let's go ahead. Now we have very interesting presentation as well. We invite for next lecture, next presentation, our industrial colleagues from company Infineon. It is German companies, and in Ukraine we have one of the sub companies of sub division of this company, and it's my pleasure invite for presentation our colleagues from this company, and I would like to invite Dr. Alexander Karpin, Dr. Orest Akimishin, Dr. Viktor Kremlin, and Alexander Pirogov. As I see, this presentation will be done by Dr. Orest Akimishin. Yes. Orest received a PhD in computer engineering from... Sorry, please switch off your microphone. Okay. Orest received PhD in computer engineering from Lviv Polytechnical National University, Ukraine in 2009. He is currently principal system engineer of Infineon Technologies, a semiconductor solution company with headquarters in Germany. Orest has 15 plus years of industry experience in embedded system solution, hardware, software, co-design, and firmware development. His research interests include IoT, firmware development methodology, security in embedded solution. Dear Orest, welcome for your presentation, and thank you for your cooperation with our DESSERT conference during a lot of time. Welcome.
Thank you, and good morning, everyone, and thanks for joining our session today. Thank you, Vyacheslav Sergeyevich, for the invite and for the nice introduction. And actually, today will be two speakers. I will present, and Dr. Victor Kremin. So if you would like, you can also present him.
Okay, because I did not present. I can present to all your team, but I think it would be better if you do it.
Yeah. Okay. Can you see my screen?
We're waiting for.
Let me try again. It's like currently an error. Sorry, an error has appeared.
Please.
I will.
Completely is okay. Welcome.
Okay. So first of all, I would like to start with some key facts that describing how our world is changing. And like three key trends are like the first is the population the population keeps growing and is projected to achieve 9.7 billion by 2050, comparing to around 8 billion in 2023. The world also is aging. What does that mean? That means that the number of people aged 65 years or older worldwide is projected to rise up to 16%, comparing to 9% in 2019. And as a result of that, the number of workers per retiree declines worldwide and is projected to decrease from around 3 to 1.5 workers per one retiree in 2050. There is strong urbanization trend, and today 56% of our population live in cities, and it's projected that this portion is expected to increase to 68% by 2050. And the humanity experience resource deficit. And what is Earth's overshot day? The Earth's overshot day marks the date when the humanity's demand for ecological resources and services in a given year exceeds what Earth can regenerate in that year. And in 2023, this date was August 2nd. And how we maintain this deficit? It's basically maintained by liquidating stocks of ecological resources and accumulating waste and primary carbon dioxide in the atmosphere. So this briefly describes where we are today and how the world is changing during our time. And of course, these changes do not come alone, and with these changes, new challenges arise. And in this portion of the presentation, the focus will be on some trends in energy saving and how we deal with the aging world going further. With strong urbanization trend, the new markets and the new challenges arise in modern cities. And those are like mobility sharing, which includes basically transportation sharing, like concurrently or one after another. Another topic is smart infrastructures, and smart infrastructure is the infrastructure that collects the data, processes the data, and take actions based on the data without people intervention, and that also dynamically adapts based on the changing condition. And the smart infrastructure typically includes smart networks, smart cities, smart lighting, smart parking lots, etc. For sure, smart structures or smart cities also include smart buildings. And smart buildings is a technology where some of the processes are automated. And examples of this are like smart heating, smart ventilation, lighting, security, and others. For sure, there is demand for digital IDs, and digital IDs, like digital identity, it allows people to access financial systems and services, including banks and also government services, irrespective from where the people are located. For resource protection, the modern trends are smart energy usage that basically includes smart monitoring, accurate measurement, and preserving of the resources. Additional, or one more trend is like smart farming, and smart farming basically allows farmers to optimize the use of resources by monitoring different metrics. For example, measuring soil moisture and rainfall levels to determine the best time to irrigate a field and reduce resources and increase the effectiveness of their lands. Circular economy solution and recycling listed here, they are not directly related to, I would say, to microelectronics industry, but that's very important directions for resource protecting. And smart building, I already touched this topic. It's basically like not only about making human lives easier, right? But it's also about energy efficiency and cost saving. For example, if we take even like a regular like thermostats that can be programmed to regulate temperature inside building, like during specified periods of time. For example, when people sleep, the temperature can be a little bit down. When people are out, the temperature can also be lower at right. And when we are home, the temperature is comfortable for our being in the home. That's like basic things, but allows to save maybe 10 or maybe 15% of the resources. Another direction is related to health tracking, assisted living, remote health monitoring, fitness monitoring, and service robotics. And health tracking and fitness monitoring can be combined in one group. It's basically presented by different fitness trackers that evolved from like simple devices that could measure only the number of steps to some modern devices that can measure the number of steps, but additionally monitor like heart rate, stress level, sleep quality, and more. And remote health monitoring, this technology allows doctors to monitor their patients outside of the clinic by constantly measured by I'm sorry, we constantly measured the patient state in real time and understanding patient disease state and enabling the provider to make proactive critical decisions. Service robotics is another important area, and that's like there are different like sub areas within this area, and one of them is like the simple robots can perform small tasks like fetching food and water. Some may be more advanced in providing some entertainment through games and helping remind elderly people events and appointments, and also providing some social engagement. There also is a class of robotic systems that provide mobility and transportation support to seniors. And of course, like domestic robots that clean floors or mow the lawns. Yeah, it's another example in that area. So all these things like are manufactured and provided to make our life safer, greener, more comfortable, and to save the resources. Since we observe the reduction in manpower, the industry also needs to be rethinked. The tasks have to be automated, and like location and assets have to be tracked automatically, and predictive maintenance should be in place, and also collaborative robots. And the popular trend today is industrial IoT that allows the systems to communicate and to communicate between each other directly, direct communication between the end devices in the fields. for sure, the rise of the adoption of IoT in everyday life, it also provides some requires some digital society expects secure global digital services, and that includes cryptocurrencies, international digital payment, authentication, remote work, e-health, and metaverse. One interesting thing, in my opinion, here is metaverse. And metaverse basically allow user to work, meet, game, and socialize together in 3D spaces. And it also supports the connections between the financial, virtual, and physical worlds. So basically, it's a concept of online 3D universe that combines multiple different virtual spaces. So, and IoT solves many challenges of our time. This is like very short summary about the IoT state today and like some projection by 2025 or 2027. So today, 127 devices hook up every second to the internet for the first time, and that number will constantly increase. The forecasted amount of data generated by IoT devices by 2025 is 73.1 zettabytes. And like it's expected that by 2027, there will be 43 billion IoT devices to be connected worldwide. So it's like huge number, like, and if you take the population of the today's population, which is roughly 8 billion, right? So that means that 5 devices per one person, irrespective of their age, right? So that's like really huge number of devices that will be connected in the next couple of years. And of course, revenue or like the market is estimated like 158 billion. That was the market size in 2022. So the challenge of our time can be solved with device-to-device communication. That's like new trend in the IoT, and the point here is that the devices do not require some like centralization, but work completely autonomously. And we also observe the trend that more and more devices are equipped with artificial intelligence, so they can operate even better autonomously without people intervention. They become more self-sufficient and even more intelligent. And one example of this that is easy to understand is, for example, when you drive back home and plug in your electric vehicle for charging, the system analyzes maybe the weather condition, maybe just simply analyze how much energy can be generated by the solar panel, and then it decides use like the power that is generated by solar panel to charge your car, or use the electricity from the grid. If, for example, if the level of the energy generated by solar panel is not sufficient, or if the system decides that you need to charge your car in a short period of time, as example. Another example of IoT device, right? It can be easily called IoT device is a heat pump. But heat pump actually it contains like multiple sensors and multiple IoT devices that work in different areas, not only IoT, but also some kind of actuators. And if we take an example, so what we have like sensing here, like multiple sensors that continuously sense and measure some parameters. Sensors are connected with a microcontroller unit. Microcontroller unit, there is a software that runs on this microcontroller unit, which performs computational, and based on this computation, it's basically actuates the devices and the processes within the heat pump. And this thing is connected to internet, so you can in real time see the performance. But probably the more important thing is if there some like error happens during the operation, the system will notify you directly, so you will be aware that something happened wrong and requires your attention. This slide is basically similar with the previous one, just like presents or better divides what components belong to what area. Like, I mean, sense, actuate, compute, secure, software, and connect. And Infineon is an industry leader in compute, connect, and security solution. So we are key player in emergency call functionality in majority cars featuring Infineon chip. We are number one in connectivity for automotive, infotainment, and printers. So we sold more than 4 billion products use compute or connectivity technologies from Infineon. This one is really impressive. Every second we are a security leader, and every second credit or debit card issued in 2021 has an Infineon security chip inside. Infineon also powers IDEs in 70 countries, representing almost 75% of world's population. And we are trusted partner to 8 of 10 IoT companies. Just like to summarize the challenges in producing new devices and new capabilities for the new markets going forward. As I mentioned before, the devices become more self-sufficient. They are equipped with artificial intelligence. The devices become more complex than ever, and like it's not a news that like even not the state of the art, but like maybe not like not standard, but some more advanced MCUs is actually equipped with like a couple CPU cores, right? And so these devices become more and more complex, and we require new methods to develop and to validate those devices. And with that, I would like to hand over to Victor, who will present how we model and develop new ways for manufacturing the new devices. Thank you.
Thank you. Welcome, Victor. Victor Kremlin, yes?
Yes, correct.
Mm-hmm. Victor, do you hear us?
One moment, please, maybe.
Mm-hmm. Yes, we see
Yeah.
Victor here. Mm-hmm.
Hello.
Hello, Victor. Welcome.
Hello. Do you see? I tried to share. Let me know if you see my screen. Do you see my screen?
Yes, we see and we hear you. Welcome.
Okay, thank you. So here I will tell about how silicon design can be accelerated with help of prototyping and how we can make new products faster according to the market trends. So I will briefly explain some glossary that is used in presentation to get some proficiency about material, what I will present here. So first is what is IP? It's in semiconductor industry. It's called as IP, some piece of logic that we can put onto chip. We can put one time, multiple times, depending on our specification. Hard IP, it's some piece of function block of chip that link it to specific implementation technology or process. Example of hard IP, it can be memory, like flash memory, dynamic memory, and so on. And soft IP is a piece of logic that can be implemented in any technology like ASIC, FPGA. It commonly comes as source code in some hardware description language like Verilog, VGL, and so on. And IP verification, where we want to check some IP function with help of simulation tool, and IP validation when we want to check IP functionality on real silicon, on its port to the FPGA or some other prototyping platform. So now we go, what are market trends in semiconductor industry? First of all, it's increasing competition. As we see strong boosting emerging markets and more companies, especially in Asia, are coming to market, and they're highly aggressive in schedules and pricing. Also, new designs are getting more and more complex and have more logics and much more difficult to design them. Also, we see silicon technology or chip industry moving to the smaller process, and a result of that, mask cost increase very rapidly. And if your technology going to the smaller nodes or smaller block element dimensions, mask cost increases exponentially. So if you read some news, some company is developing, let's say, 7 nanometers, 5 nanometers process, please remember masks are very expensive for that. And modern chip, it's nothing works without software. It's programmable device. It's when customers need to have drivers, software tools, port of real-time operation system, and complete ecosystem to enable them develop their application quickly and in highly productive way. And also solutions need to be compliant with various industry standards. So if you do software for auto, you need to be compliant with some ISO 26262 standard. Solution need to be certified for emission, electromagnetic compatibility requirements. If you have a radio need to be certified as well for multiple tests to ensure nothing wrong and your system does not disturb others or it's within limits. And if you have any communication interfaces like USB, Ethernet, video, all those PCI Express, all those interfaces need to be compliant test. So it's a lot of challenges as we have higher speed, smaller technology nodes, increasing competition, and how we can address those challenges. So simulation for chip design verification through simulators, it has been used for a long period of time for design verification. But it's time expensive, and some simulations might take days or weeks, even on the world most powerful farms. So how we can accelerate chip designs with help of prototyping? In here, I will cover what does mean virtual prototyping, discrete components prototype, test chip, a standalone IP port to FPGA, complete design port to a single FPGA chip, and about emulation platforms. So let's start from prototyping with help of discrete components. When you design a new chip, that might be some new sensing methods or new analog or mixed signal IP. And in many cases, it's possible to prototype this new functionality with help of existing product and add some external components to mimic new mods. So it's especially good if you cannot design test chip, or test chip is expensive, or there are some other limitations. So your actual implementation is not so 100% same as in silicon, but in function transfer equivalent. So it's powerful tool, especially for system level tests and software firmware development acceleration, as from user, it's almost the same as a final silicon. Second is very powerful, very commonly used approach is designing test chip. If you have some mixed signal IP, like ADC, radio, touch controllers, or you have some physical layers, transceivers like USB, LIN, CAN, Gigabit Ethernet, or you have new silicon technology process which you want to evaluate, or some memory technology, test chip is must-have tool. So basically, test chip is custom chip that we design to test only some new portion of IP of product that cannot be prototyped in some other ways because it's expensive. And if you do a kind of soft IP development like new DSP core, AI, MI accelerator, or video graphic engine communication module, it's very convenient to just take this IP, put on some small and cheap FPGA that has own hard IP CPU subsystem and play with this new UIP. It's cheap, fast, and helpful for software development, as we use this tool regularly for new IP validation on FPGAs. And if you have full chip and it's this full chip like some new microcontroller with a lot of peripherals, processors, memory, and you can put your product on some one FPGA, you can take existing board, kit, and put your product on silicon and see how it works. Sorry, on FPGA, and see how it works with help of this FPGA port. It's very powerful tool, as you can develop a lot of software, lot of application code, perform IP validation on FPGA, develop lot of tests for IP, and debug your models. So I show some examples of boards that we use for our papers at regular daily base. It's on-the-shelf board. Never design your own FPGA board. So no sense. And if you have some big design that cannot fit in one FPGA, but you want to validate its functionality, the emulation platforms come to service, and some vendors provide big farms of FPGA, and they give some special tools that enable you splitting your huge design on multiple FPGA in kind of semi-automated way, where this splitting is module-based. This tool can add some interconnection buses and some other tools, so you can do accurate emulation of your system, but at lower clock. So it's expensive, it's difficult to work, it's time consuming, but it gives you big acceleration advantage in terms of new product verification and validation on FPGA. And last but not least, it's virtual prototype. Virtual prototype is a kind of set of system C models for each block that mimics model transfer function functionality or transaction-based operation, mimics register set, but it's not accurate in terms of execution speed, so it's more function models. And those models developed by design team together with IP, it's with Verilog or VHDL code, and they might be helpful for customer software development or IP validation. So in our practice, we sometimes develop those models for IP that we work on, and they are helpful for overall function IP analysis. And here I give some nutshell summary of different prototyping techniques. So the discrete prototype technique is fast, cheap, low cost, fast turnaround, but it has serious limitations for different application usage, as you cannot accurately mimic your function with help of discrete components. Test chip is very powerful tool where you can evaluate some new portion of IP, and test chip can be combined in efficient way to FPGA platform, let's say for radio, for analog front ends, for transceivers, video, and other purposes. If you have some new model that you want to put in FPGA with no full chip code availability, you can just take this IP and put onto a small FPGA. And if your code is for your product is sufficient to put on one FPGA, it's you can put on single FPGA chip and deliver this platform to customers, like some customers who develop application level drivers and other components, and this platform is highly useful for acceleration of chip development and commonly used by our company. And virtual prototypes, it's alternative way. It's restricted in terms of usage, but still helpful as no hardware interaction is needed. So that basically a summary of different prototyping techniques that developed used for new products, new silicon development. And in last slide, I just tell a few words. As Oris mentioned it, strong innovation focus for new product development. So our site in Lviv contribute a lot of innovations for company. We authors more than 200 US patents, and multiple applications are pending in area of touch, capsense, fingerprint, human-machine interface, machine learning, and IoT products. So that's it from my side. Do you have any questions to me or Orest?
Okay, thank you very much, Oris. Thank you very much, Victor, for your presentation. It's absolutely extreme result where you have your company, Ukrainian division has 200 United States patents. I think it's one of the record in Ukraine, and maybe not only. Okay, dear colleagues.
So I think it's innovation is key for success, for product success, especially in terms of creating, differentiating value for new things.
Thank you. Okay, we have time for question and discussion. First question, Dr. Artem Perepelitsin. Welcome, Artem.
Thank you. Thank you for your really interesting report. And there are a lot of interesting and new things were presented. But very short question about the lines of chips. And the question is, did you check the chips and products with on-chip memory, HBM memory, high bandwidth memory? Just yes or no? Because
So-
you mentioned a lot of cards, and some cards, but not that cards that you mentioned, includes the on-chip 4, 8, 16, and 32 gigabits of on-chip dynamic memory connected directly to the chip inside the same package. Okay.
So answer is basically we, as I know, our company does not produce chips in package that have how to say one package, but some microcontroller or some microprocessor die and memory die in one package. So, but our chips have functionality to interface external memory and have on-chip memory for data storage like SRAM memory or flash memory for program.
Okay, thank you.
Other questions? I thought that Artem asked about FPGA security issues because Artem developed courses on FPGA security or about FPGA as an object for cyber attacks and application FPGA for cyber security providing. My question.
So maybe
my-
I just can add. So in our company, FPGAs are used just for prototyping. They are not of part any products, or we do not develop and sell FPGA itself. It means
I see.
so. Yeah, please.
Yeah, yes, we understand this issue, but a question about cybersecurity issues as a part of your design, and cybersecurity of FPGA and hardware as well. I mean, which problems as engineers you see in area hardware and hardware security for such embedded system? As I see, it is a safety critical system if used in automotive or any other system. Your opinion?
Maybe Oris can answer that for ICW products, and I may give some headlights for auto products.
Like a sector side, FPGA platforms are now delivered to external customers, so they are used internally to simulate our future hardware and start software hardware code design at early phase. For example, I am responsible for the boot firmware development, which is programmed to ROM memory directly during chip manufacturing. So it's immutable. It cannot be changed after chip is produced. The only way to fix bug or to add some new feature is like a new chip respin, which costs pretty much. And from security purposes, like for sure we develop secure boot firmware for our devices, which includes authentication of next image before transferring control to that image. We also support secure debugs, secure manufacturing, secure provisioning, all that kind of things. I'm not sure that maybe it's like directly related to the question. Maybe I would like.
Yeah, your question is understandable. Maybe more detailed question related to in your practice situation when you search some hardware or FPGA vulnerability as off-the-shelf decision which you used in your project.
No.
Vulnerabilities of hardware or FPGA-based decision.
Not for FPGA-based decision. We definitely search for vulnerabilities in our product. For example, our product has to be secured against fault injection attack, which is very common and very popular nowadays. Like when an attacker has the capability to has physical access to attack, and they are like different equipment to making this kind of attack are actually becoming more and more available to general market, and they are like cost like between maybe $50 and $100, and this equipment can be used to perform like physical attacks on the chip and trying to insert the glitch during code execution, so that like some instruction that can be skipped with clock glitch or voltage glitch. So we have a penetration lab where we inspect our devices and search those vulnerabilities, and we also come up with methods to protect our devices against such vulnerabilities and against hardware attack. And we use combined like hardware and software methods, since like do everything in hardware is very complicated, and software do everything in software will result in slow system, slow response, and just doing in software is not sufficient nowadays. Yeah, so we are trying to find good combination of hardware and software in order to protect our chip from such kinds of attacks. And Infineon is really it's key player in security. And as I said during my presentation, that like every second credit or debit card issued in 2021 has Infineon security chip inside.
Okay. Thank you very much. It's a very interesting point because we are going with development of penetration testing for embedded system and hardware vulnerability for robotics, for any other system. It's a very interesting and hot topic. And I have one short question more. Victor mentioned standard 26226. It's a standard on functional safety of automotive system. One of the requirements of these standards, as I remember, is application of diversity for safety critical systems, similar acceleration, control, and so on. I mean, application of hardware and software diversity. When we use two different platforms, two different software versions to minimize risk of common cause failure. Any example from your practice in this context, or your opinion about application of these such principles to meet requirements of these standards?
Answer is I do not know, as we basically do not develop application level software, but our teams are involved into development some low level drivers or some components for that. So it means and they are developed accordingly to the standard according to processes and test coverage with corresponding test coverage and all supporting documentation. But I do not tell nothing. I can tell nothing about usage this principle.
Okay, thank you. Thank you very much, Oris. Thank you very much, Victor. Thank you very much, your team and your company for interesting presentation and interesting talk. Thank you. And now we need to go ahead. Now short interrupt of our session. After short time, we will continue our session. We need to hold 3 separated sessions. And I would like to ask all moderators to start this session 5 minutes later. And short information about our final sessions. We would like invite all participants on very interesting special event at 1 p.m. today. It will be special session on development of space civilization in context of problem safety, security, and dependability in the world. And after this session, we will invite you in our closed session at 2 p.m. I think 20 minutes will be enough to close our conference. Thank you very much for your attention, and please continue our work in sessions and finalize our work in separated session. Thank you. Any questions? No. Okay. Continue our work.